a 3D view of a beam. Okay, so this is a 3D view. So we have three axes: X, Y, and Z. Just wait. Everyone is joining from their WhatsApp group. Their joining request. I need to admit. So this is a 3D view of beam. So we have three axes. See, this y-axis, this one is known as. You have to basically there are some terms. This is known as axis of symmetry. Okay, why axis of symmetry? Because see, in this section, y, the both the cross-sectional area is symmetric about this axis. That's why it is known as axis of symmetry. And this x direction, this one, this is known as longitudinal axis, and this is uh, z axis. Okay, it have a name. So if in case of bending, after applying, if you apply any external load, the beam will, suppose the beam has bent in this way. Okay, so a moment, that is this m, will generate in this section, and corresponding an anti-clockwise movement is also generated. So if you take a small section here, if you consider just a small section here that is undeformed, before deformation, if you consider a small section here, let us paint it with a color. If we just suppose we have painted this section with a color, black color, let's say. So after bending, what happens? The cross section will deform in this way. In the top fiber, it will not actually change its shape. It will remain its original shape in the topmost fiber. And the bottom, it will the strain will be maximum. Okay, so in this way, in this fashion, the cross section will bend. And if you consider this axis, that is known as longitudinal axis, in upper part it will be compression, and in the lower part it will be tension, isn't it? In the top fiber, see, these points are have compressed. If you go upward, this will have compression, and in the downward side it will be in tension. Just consider this. If you take a point here, in the upper part, the points will go in this way. Let's do it. Let us add. Okay, so this point is known as neutral point, because in this point no deformation has occurred. So this point is known as neutral point. Okay, and what else? So these are the things basically we will discuss. It is what's going on with the fibers, and what are the assumptions in the bending theory, what are the assumptions. Then we'll derive the flexure formula. This is also known as theory of bending. Okay, and we'll see these points: the strain along a fiber, stress along a fiber, and force analysis and moment analysis. So I am telling fiber. So what is this fibers actually? See, this is a beam. Now if you consider a small wear between, this is a combination of wears. If you just assume that, so small portion, micro portion, after bending these fibers, if you consider a particular fiber, there is a beam is a combination of, let us assume these are fibers. Okay, so we'll deal with these fibers, the state, stress, strain, force, moment, these things, with considering the beam as a fiber. So tomorrow onwards, see, after 15 minutes to the beginning of the class, after 15 minutes, I will not admit anyone from tomorrow onwards. Remember that, because in between, this is very difficult. It is cause disturbance. Understood? You have to be in class in time. Okay. So whatever we have to assume some things. In case of bending of beams, there are some assumptions. So your number one is the beam has to be homogeneous. So homogeneous means it's the same composition. That means the whole thing have to build with the same composition. Okay, that means homogeneous. Number two, your cross-sectional area, this one, cross-sectional area is symmetrical with respect to only one axis, that is y-axis. See, this is the cross-section of the beam and this is the y-axis. So the cross-section is symmetrical with respect to the y-axis. That is number two. And number three is bending moment, that is
The number two is what? The number two, repeat please.
This is cross-sectional area. Number two, this cross-sectional area is symmetrical with respect to one axis. Symmetrical, bujo, what is symmetrical? And that means the area is same.
Yes.
The axis
Both sides same.
axis is there, y-axis is right side and left side, area is same. That means symmetrical. Okay. Number three, bending moment is applied with respect to an axis that is parallel to axis of symmetry. That is, we'll calculate the bending moment with respect to these axes. That is z-axis. This is actually 3D view. That's why you have to understand this. So the beam will bend like this way, this way. So if this is z-axis, the bending moment are calculated with respect to z-axis. Okay, the beam will elongate with respect to x-axis only, but the bending moment will calculate with respect to this axis, z-axis. So, and in assumption 3, what is they are telling that it has to be perpendicular with respect to axis of symmetry. So your y is your axis of symmetry, and it is perpendicular. Yes, see. And what is assumption 4? Poisson's effect neglected. That means we are neglecting the Poisson's effect. So if you remember, what is Poisson's effect? It basically connects the two types of strain, that is longitudinal and lateral strain. Okay, so if you the beam is bending, so it will elongate in x direction, but its length in y direction will be reduced, isn't it? If it extends in x direction, the dimension in y will be reduced. Sorry, here it is.
Sir,
It should be reduced. Yeah. Yes.
please explain it again. Actually, the voice is disturbing. That's why.
Was it
Yes, sir.
now?
We can't hear properly.
Okay. Is it okay now?
Yes,
Yes,
sir. Now it's
now
okay.
it's okay.
It is okay now?
Yes, sir.
শোনা যায়? আচ্ছা ঠিক আছে ঠিক আছে। So আমি যেটা বলছিলাম Poisson's effect. This thing you already know. What is Poisson's effect? See, if this is a beam, this is the original sheet, x and y dimension. Now, if you extend this one with respect to x-axis, in x direction, what happens? The beam is length is will increase, but in y direction, see, the length will decrease. So we will neglect this effect while deriving the flexure formula. We will neglect this uh, reduction of length in the y direction. Okay, we'll only consider the increase of length in x direction only. That is the assumption here. Okay. And what is number 5? Cross sectional area will retain its shape. That means after removal of your external load, your cross sectional area will retain its original shape and size. That means they are basically trying to say that up to proportional limit, up to proportional or elastic limit, the load has to be applied. That point number 5. Okay. And number 6 is neutral plane, also known as, that is aka, also known as neutral surface. So what is neutral surface then? See, this is the neutral axis, that is z. This is I shortly written as NA, which is neutral axis. Okay, and it is in the xy plane. This one, can you see the pointer? Which is, it's not in
Yes,
slide,
sir.
so I don't know whether you can see on it. It is visible, na pointer?
Yes, sir.
Yes.
Okay, so this plane is known as neutral plane or neutral surface, because in this plane there will be no deformation. We have what happens in the top fiber. See, this is the neutral plane or longitudinal axis. In the top fiber it will be compression, and in the bottom fiber it will be uh, sorry, yes, bottom fiber it will be tension. But in the
Tension.
neutral axis there will be no deformation. It will curve. The after deformation the neutral plane will be in curve, but the total length will be same. It may be straight or may be curved, but the total length will be same. So what is number 1 assumption? The material is homogeneous. Cross sectional area is symmetrical with respect to one axis, that is y axis. Bending moment applied with respect to an axis that is perpendicular to axis of symmetry. Number 4, your Poisson's effect is neglected. Number 5, cross sectional area retain its shape and size. And number 6, your neutral plane will be also known as neutral surface. Okay, fine. That thing we have assumed. Still joining request are coming, so just no, these two things. Yes, yes.
Sir, assumption है sir neutral plane at a neutral surface লিখা ছিল sir.
Neutral plane.
Neutral plane at a neutral surface.
AKA means also known as. Shortly, it is written as AKA.
Okay, sir.
That is okay. This is a short form. Okay. So now, our objective is to derive the flexure formula. Okay, just theory of bending. So for this, Let us consider this section, the cross sectional area, that is this section only, this one. So this is the section before the loading, and this is the section after bending. Okay, so this length, it is longitudinal axis, this dimension is del x. Let us consider this is del x, the length, and from del x at a height of y, let us consider another fiber, that is a and b. In today's class, please pay attention, because there are a lot of things you need to be understand. Okay, so if you miss anything, the next step you will not understand. So this at a height of y, we have considered another fiber, that is AB, and its length is del s. So after deformation, it will be, it is neutral, it is on neutral plane, so del x will remain del x only. But this one, let us this is del s dash, only a dash, and the distance is y. See, so you know how to calculate the arc length. This is an arc, let us say this is an arc, s is the arc length. Arc means it's a part of a circle. Okay, so this is s, this is arc length, and this is the radius of curvature. This r is known as radius of curvature, and this is the angle theta. So there is a relationship that theta is equal to length of the arc divided by radius of curvature. That is, theta is equal to s by r. So what is this arc length s? S is theta into r. This is a basic geometric formula. Theta s is equal to theta r. Okay. The same thing here. If you extend this line dot to a to O, and that side B, from B to O, so you will find this angle, it is del theta. Okay, and this length O to del x, this is rho. Okay, so what will be this length O to B? It is OB. It will be rho minus y, because total is rho and this is y, so it will be rho minus y. Okay, this del x, I have already told you, this del x, this is a straight line, and this is curve. This is before deformation and this is after deformation. Length will be same. So we want to calculate the strain. So what is strain? আচ্ছা বলো তো, কার মনে আছে দেখি।
Change in length by original.
কে বলছো? Which
It,
what is strain?
the change in length by original.
Changing the original length.
That is change in length by original length. It may be
Yes, sir.
it also. That means change in dimension divided by original dimension.
Original dimension.
So see, this is, and it is represented by epsilon. So your strain is that is final minus initial. I have written here shortly. Final minus initial divided by initial. This is the change in dimension divided by original dimension. That means del s dash, that is the after deformation, minus del s divided by del s. So just put this value from this formula, s is equal to theta r. That means del s, this arc length, del s dash is equal to rho minus y del theta minus rho del theta. Okay, final minus initial divided by initial. এই জায়গাটা বোঝা গেছে? Anyone have any doubt? I can explain again. Okay, so this is we are
আবার একটু বলো তো টেল।
এটা কিভাবে আসছে না দেখো, এই জায়গাটা বুঝতে লাগবে। দিস ইজ আর্ক, হ্যাঁ, দিস ইজ দ্য,
স্যার এটা বুঝেছি যে রো মাইনাস ওয়াইটা কি করে এসছে, মানে
হ্যাঁ র মাইনাস
ওই
ওয়াইটা কি করে,
এটার পার্টটা বুঝি না আর কি, ফাইনাল মাইনাস ইনিশিয়াল।
হ্যাঁ হ্যাঁ দেখো,
এটা বুঝেছি রো মাইনাস ওয়াইটা কি করে এসছে।
দেখো, this is del s dash a to b, okay, and this is del s.
ওকে
So we are just uh, this formula you are using, s is equal to theta r, to find out this value. See, this is the arc,
ওকে
this is the arc. What is the
ইয়েস স্যার।
angle theta? So here it is del theta, and what is the
থিটা
radius of,
ইন্টু আর,
yes, yes, this formula only.
আর ওকে ওকে 5 মাইনাস ওয়াই, সরি নট 5, রো মাইনাস ওয়াই।
Yeah, so this will give us the formula, this one,
ওকে স্যার।
the strain along the fiber, this point, strain along a fiber. So if I take any other section, we can similarly calculate this one value. Okay, so if you simplify this one, you'll get epsilon y will be minus y by p, this formula, because your rho del theta will be cancelled out, minus and plus, will have minus y del theta by rho del theta, that is minus y by rho, that is minus y by rho. This is our equation number 1. So see, this is the fiber, this is the original length del x, this is at a height of y, this is del s. So above this longitudinal axis, this is known as zone of compression, and this is known as zone of tension, isn't it? So where will be the maximum, your maximum compression? If it is
At the
zone
top
of,
of the beam.
yes, this is the topmost fiber. Okay, so your maximum strain, it is this one, maximum strain will be at the top fiber. So let us take this distance as c, that was y, it is c. So you can replace this one, that is c by t, and we are neglecting this minus sign. We can do this just taking the value. This plus minus is only whether it is tension or compression. Okay,
Sir, for mod it is removed or what?
Mod means that we are only taking the value, there is no positive or negative thing.
Negative.
Okay, so if I give a number, suppose mod 2, that means only plus 2 positive values. Okay.
Okay, sir.
Okay. So if you place take y as positive in this formula, what will happen? Your strain will be negative. If the value of y is positive, the result will be negative. That means it is compression, isn't it? This is y. So what if you take y negative, the result strain will give positive value. That means it is tensile. See, y negative means what? Y negative means you are going downward. Y positive we are taking from this axis. So positive means we are going upward, and negative means we are going downward. So in the downward direction, it is tension. Same thing. The formula, if you put y as positive, you'll get y as negative, you'll get strain positive. That means it is tensile. So this is the formula. If you divide equation 1 by 2, this equation by this equation, that is epsilon y by epsilon max, you'll find this expression. This is a very important expression. That is strain along y will be minus y by c maximum strain. This is the formula. Okay, so what is next?
So negative positive did not understand. How it will be negative, how it will be positive.
মানে ওয়াইটা কিভাবে পজিটিভ কিভাবে
Negative
নেগেটিভ
positive. Yes, sir.
হ্যাঁ বলছি হ্যাঁ দেখ বললাম এখানে
স্যার ওয়াইটা এটা নিউট্রাল এক্সিস এর উপর ডিপেন্ড করবে না, যে নিউট্রাল এক্সিস এর উপরে গেলে এটা পজিটিভ হয়ে যায়, নিচে আসলে এটা নেগেটিভ হয়ে যায়।
নেগেটিভ হ্যাঁ জাস্ট ইউ কনসিডার দিস পিকচার হ্যাঁ this is your neutral axis, your longitudinal axis, that will be, you'll see this is also our neutral axis. So we have taken this fiber at a distance y from the neutral axis in upward direction. ঠিক আছে? So if you y positive means you are going to the upward direction. See, if y is the depth, isn't it? So negative depth, that means negative means what? You are going downward. একটা অ্যাক্সিস যখন সাপোজ উই আর হ্যাভিং এক্স অ্যাক্সিস এর উপরে কি থাকে পজিটিভ ভ্যালু, এক্স অ্যাক্সিস এর নিচে অ্যাক্সিস কি হয় নেগেটিভ। বুঝা গেল?
স্যার স্যার
ক্লিয়ার?
আরেকবার একটু স্ক্রিনটা একটু বুঝে দাও স্যার।
সিম্পল জিনিস তো। y positive means what? We are going upward direction. This is a axis.
স্যার এপসাইলন ওয়াই থেকে স্যার।
Epsilon means this is strain.
না না স্যার মানে এপসাইলন ওয়াই থেকে একটু স্ট্রেনটা স্যার কিভাবে এসছে আবার একটু বুঝে দিতে।
So equation number 1 তা না এটা?
হ্যাঁ স্যার।
এটা?
না না স্যার ইকুয়েশন নাম্বার 1 থেকে।
হ্যাঁ ইকুয়েশন নাম্বারটা 1 কিভাবে এলো? এই ফর্মুলা এই জায়গাটা বুঝতে পেরেছো? এই জায়গাটা এই তিনটা স্টেপ যেটা বললাম।
হ্যাঁ স্যার ওই চেঞ্জ ইন স্ট্রেন বারবার চেঞ্জ।
হ্যাঁ ফাইনাল মাইনাস ইনিশিয়াল করেছি, তারপরে দেখো এটাকে সিম্পলিফাই করেছি। হ্যাঁ জাস্ট মাল্টিপ্লিকেশন উইথ ডেল থিটা, this one, so this one and this one will be cancelled out. Del theta cancel, so what will remain? Minus y by rho only.
ওকে স্যার।
ঠিক আছে, and this
স্যার ম্যাক্সিমাম
আর ইকুয়েশন নাম্বার 3 দেখো এই জায়গা এটা ফিজিক্যালি বুঝতে লাগবে। দেখো maximum strain means what? This is our fiber. So where from this picture you tell me what is the maximum strain or maximum compression? This picture, which point there will be maximum compression? This is the neutral axis, this is compression zone, and below it is tension zone. Okay,
স্যার টপে হচ্ছে কমপ্লিট।
top fiber is the most maximum strain will occur. Just think of it, in the topmost fiber it will have the maximum amount of compression, so strain will also will be maximum. That is why we have taken this as c. The distance is here c, so in place of y this is c by rho. Okay,
ওকে স্যার।
so this is our final equation. From this picture you will have a better idea. See,
স্যার রেশিওটা কি কম্পেয়ার করা হয়েছে স্যার? স্যার ইকুয়েশন 1 and 2 কি কম্পেয়ার করা হয়েছে স্যার? নিচে এপসাইলন ওয়াই ইজ ইকুয়াল টু
compare now. We have divided equation 1 by 2, right hand side and left hand side, just division. একটা ইকুয়েশন আরেকটা ইকুয়েশন দিয়ে ডিভাইড করলাম আমরা, ঠিক আছে? You can do that.
ওকে স্যার।
See this picture, you'll get a better idea. This is our neutral axis, this x along x axis, and in the topmost fiber, that is maximum strain is c by rho. Okay, and at a distance y, epsilon y means the distance is y, that is depth is y, it is minus y by c E max. This that was our equation, this equation. Okay. Okay. Next, let me show it in slide note. Now consider this second one. Strain we have done, is complete. Now stress along a fiber. So in the assumption, if you remember, I have told that we will only take up to the proportional limit or elastic limit. We'll consider only up to elastic limit. So from this formula, that is E, this is Young's modulus. Okay, stress is proportional to strain. So from that formula, we derive strain is equal to sigma by E. E epsilon is strain, sigma is your stress, and E is Young's modulus. Okay. So in this formula, you just put the values of the previous one. See, values of this epsilon. So sigma y by E is equal to minus y by c sigma max by E. Okay. So E and E will be cancelled out. So what will remain? Sigma y equal to minus y by c sigma max. Just this equation number 1 is for strain, and see in this equation it is for stress. Just we are converting this strain into stress. That's all. And one more thing. See, this is the neutral axis, and in the topmost fiber, this is the known as compression zone, or shortly here it is mentioned as RC. That is resultant of compression. In the all of the fibers, there will be compression. This is this fiber one, this one, this one, this one. So there will be a resultant of compression. So this is RC. And in the bottom fiber, similarly, all the fibers will go to tension. So there the resultant will be, let us consider it as RT. So your RC plus RT, that is your resultant of your compression as well as tension, the summation will be 0. But the moment will generate will not be equal to 0. See, if it is RC and it is RT, the direction is just opposite. It is going this direction, and RT, the resultant, is going to that direction. So this will form a couple, isn't it? Two parallel forces acting at a distance x. So they will form a couple. So this is moment of a couple if you multiply this with the distance. But the moment will not be equal to 0. There will be a moment. Okay. It is clear. The resultant of compression plus tension.
Moment portion.
Moment portion. The resultant of compression plus tension, the summation will be 0 because it is in equilibrium, isn't it?
Yes, sir.
The resultant of your compression plus tension, it will be 0. But the moment is not here 0. Because you are applying a load. So if this is acting, the resultant is acting in this direction RC, and the tension it is in this direction, and the distance is x. So there will be a moment, isn't it? There is a value. Force into distance. Moment is what? Force into distance. So there will be a value.
Distance.
I am saying that RC plus RT is equal to 0. One is compression, one is tension. but their movement will be not zero. As simple as that. Okay.
Yes, sir.
The same thing. Okay, so this is basically what. Oh, this is the this thing I have already told you. This is if the beam is bent like this way. This is known as sagging of the beam. So when is your next class?
11:15.
11:15.
Oh, okay. এটা complete করা যাবে না। আচ্ছা, till now, have you any doubt? Because if you have any doubt, we will not can't proceed. From the first slide, just if you have any doubt or confusion, ask. Assumption, any doubt? How I have derived this formula, this thing.
Clear, sir.
Okay, sir.
Clear.
Sure, sir.
Clear.
এটা পজিটিভ নেগেটিভ কিভাবে এলো টেনশন
স্যার এই নিচের পার্টটা একটু এই যে কম্পেয়ারের পার্টটা একটু আবার যদি করে দাও।
মানে ওই যে ডিভাইড করলাম যেটা
হ্যাঁ
এটা
হ্যাঁ
দেখো
হ্যাঁ
Sir, positive,
see
negative.
equation number 1 equation number is what we are taking this section AB at a
Yes, sir.
distance y so this equation is for this distance y for this fiber AB
ওকে
and C is for the top fiber. Let us say
Top
this is
fiber.
PQ. I haven't tried. Let us it is PQ. So the distance is C.
Yes, sir.
That is the depth is C. So if you just in place of Y, it is C. So it is maximum strain. The topmost fiber, the maximum strain.
Yes,
So
sir.
it
Yes,
is
okay.
C by P. Okay. You can write it minus C by rho also. No problem. Plus minus here represent only the compression and tension. Okay, no problem. For the sake of simplicity, I have taken as it is mod positive value. That's all. No confusion. Now, if we are dividing this equation number 1 by 2. So, if you divide 1 by 2, that is divide the left hand side first, then right hand side, and ultimately you will get this.
Okay.
Okay.
Okay, sir.
And
Sir, sir, there is y plus, and for the strain is negative, sir, and
What?
y negative and tensile positive.
Acha, you tell me. When you plot a graph, you suppose you have x-axis and y-axis. So suppose you are having x-axis. X-axis এর উপরে কি থাকে আর নিচের ভ্যালু কি থাকে? What are the values above the x and below y x?
Above is positive and below is negative.
Okay, that thing you understood. Now see, this is our line. This is our line. So y negative. Y is what? Y is depth or distance. That is height. If you consider this y is positive, that means it is height. And if it is negative, it is deep. That means depth, isn't it? From a line, if you go above, the distance is known as height. And if you go below, it is depth. Just y positive means we are going upward. And y negative means it is
Downward direction.
ডাউনওয়ার্ড ডাইরেকশন ডিসটেন্স কি কোন সময় নেগেটিভ হতে পারে পারে না y তো একটা ডিসটেন্স তো নেগেটিভ কোন সময় হতে পারে না তো পজিটিভ মিন্স ইট ইজ হাইট এন্ড নেগেটিভ মিন্স ইট ইজ ডেপথ দ্যাটস অল ক্লিয়ার
Sir,
ওকে
স্যার y প্লাস তো উপরে পজিটিভ হচ্ছে তাহলে সো কম্পারেশন তো স্যার নেগেটিভ মানে এপসাইলন যে সব
এই ইকুয়েশনে
না স্যার ওই যে স্যার y পজিটিভ আর নেগেটিভ যে হয়েছে আর এপসাইলন পজিটিভ নেগেটিভ হয়েছে
হ্যাঁ দেখো এই ইকুয়েশন নাম্বার 1, if you put y as positive, that means your y value is positive. ইকুয়েশন আগে থেকে এটা মাইনাস আছে না, there is already a minus, so your strain will be negative. ঠিক আছে, and if you y values are negative, that means you are going downward, so minus minus it will be positive.
Positive.
So strain positive means it is tensile. Same thing, if you go upward side, the strain is, we already know this is compression and this is tension. Same thing here on. So four more parts: force analysis and moment analysis. This and force and moment, and after this we will derive the Flexure formula. So আজকে তো টাইম নেই আর, ঠিক আছে, we'll do it tomorrow.
Thank you, sir.
You can leave now.
Thank you, sir.
রূপন, তা কাল ক্লাস তো, আজকের ক্লাস তো শেষ, এখন জয়েন করে কি করবে? রূপন, কি হলো, শুনতে পারছো রূপন?
হ্যালো স্যার।
হ্যাঁ, আজকের ক্লাস শেষ তো অলরেডি।
স্যার আমার একটু প্রবলেম ছিল, তার জন্য স্যার বাইরে গিয়েছিলাম, ওই লেট হয়ে গেছে স্যার। সরি স্যার, নেক্সট টাইম হবে না স্যার।
হ্যাঁ, ক্লাসের টাইম টেবিলটা দেখো। ঠিক আছে,
ওকে
আমি
স্যার।
অ্যাটেন্ডেন্স দিয়ে দেবো। ঠিক আছে,
ওকে স্যার।
আর কি, কেমন আছো?
ভালো আছে স্যার, আপনি?
হ্যাঁ, আছি ভালো। ঠিক আছে
স্যার আপনি কি ফটিকরা না আগরতলা?
এখন তো বাড়িতেই আছি, ইউনিভার্সিটি তো
ও,
লকডাউনের পরে আর
ওই সেদিন
আইতে
সেদিন
পারলাম না।
দেখেছিলাম আপনাকে স্যার, ফটিকরাই,
হুম।
আপনার
ও,
বাড়ির সামনে।
ও,
ওই
দেখা
বিক্টরের
করলে না?
বাড়িতে গিয়েছিলাম, সেই সময় দেখেছিলাম স্যার।
দেখা করলে না?
স্যার আমি একটু বিজি ছিলাম, তার জন্য তাড়াতাড়ি চলে এসেছিলাম, ওই বাইকে একটু স্পিডও ছিল তখন।
ও, আচ্ছা, ঠিক আছে, হ্যাঁ।
ওকে স্যার।
হুম।